Welcome everyone. The question is the magnetic field through a circular loop wire 12 centimeter in radius and 8.5 ohm resistance changes with time as shown in the figure. So just try to understand that it is basically talking about a circular loop of wire. Circular loop of wire. Something like this. Its radius is given. Radius is 12 centimeter. The radius is 12 centimeter here, and the resistance of the wire, obviously since it has some length 2 pi r, that is 2 pi into 12, that's why it having the resistance 8.5 ohm, that is the capital R equal to 8.5 ohm. Okay, changes with time. Which is changes? The magnetic field here changes as shown in the figure. So magnetic field is plotted along the y-axis and the time is plotted along the x-axis. When the time is just increases from 0 to 2, the magnetic field is increases from 0 to 1 Tesla. Again see, when the time is increases from 2 to 4, the magnetic field increases from, no, not increases, it remains constant at 1. When the time is increases from 4 to 6, time becomes 4 to 6. In this interval, the magnetic field decreases from 1 to 0. So here the magnetic field is basically nothing but changes with time as shown in the figure. The magnetic field is perpendicular to that of the plane of the loop here. That means let us consider the magnetic field is upward and perpendicular to that of the plane of the paper as shown in the figure. Okay, it is uniform, and in this region it is changing uniformly, and it is perpendicular to that of the plane of the loop, and here perpendicular to that of the plane of the paper. Calculate the current induced in the loop and plot a graph showing the induced current as a function of time. So you know that from the law of electromagnetic inductions, there are three laws of electromagnetic inductions. The first law says, let us recapitulate this. Whenever the magnetic flux through any coil, okay, through a circuit changes with time, the induced current or the current will be induced. Okay. Second law says, that is a capital E, the EMF induced in the circuit. Okay, that's why the current flows. It is proportional to the rate of change of magnetic flux. If the magnetic flux changes at a greater rate, more EMF will be induced. And the Lentz's law after that says that uh, the current will be induced in a direction such that it opposes the cause. So there is a negative sign for it. Okay, there is a negative sign for it. So we can say simply these relations simply gives you, if we avoid the proportionality side, then we have to introduce a equal to sign, and we have to consider the constant of proportionality as 1. Then under this consideration, the EMF induced E is equal to minus of d phi by dt. Minus of d phi by dt. And the magnetic flux is defined as phi is equal to capital B dot A. Okay, that means the magnetic field intensity multiplied by the area of the loop, and this will become BA cos theta, where theta is nothing but the angle between the magnetic field vector and the area vector. The area vector is always perpendicular to that of the loop, and since here we have considered that the magnetic field is also perpendicular to that of the loop, so in that particular case, the angle between the direction of the area of the loop, which is also perpendicular, magnetic field is also perpendicular. In that particular case, we can say cos theta is 0 degree. Since cos theta is 0 degree, so it is BA. But here this phi is a function of time because the b is a function of time. So let us write this. Here the b, that is the magnetic field. The magnetic field is a function of time here. Since the magnetic field is a function of time, then obviously due to this, the phi t, that is the magnetic flux, is changing. So from this figure it is shown that from t equal to 0 to t equal to 2, that is the first 2-second interval, the magnetic field changes from 0 to 1. So when t equal to 0 to t equal to 2, in that particular interval, the magnetic field is basically changes from 0 value. The magnetic field is changes from 0 value to 1 value, from 0 Tesla to 1 Tesla. That is the magnetic field is change. So if I say the change in magnetic field here, that is the del B. Okay, del B. What is del B here? Del B is magnetic field at 2 seconds minus magnetic field at 1 second. Okay, then what is del phi? Del phi is del B multiplied by A. So here it is B2 minus B1. What is B2? Magnetic field at 2. What is the value of the magnetic field at 2? That is 1 Tesla. What is the value of magnetic field at magnetic field at 0 second? That is 0 here. So the magnetic field change is 1 Tesla. So this will become 1 Tesla multiplied by the area. What is the area? Pi r square here, and the value of the r is given. So that is in Weber. Okay. And what is the time interval here? Obviously time interval is del t equal to 2 minus 0. Del t equal to 2 minus 0 second, that is 2 second. Okay. So from this curve, that is from t equal to 0 to t equal to 2, up to this, what is the value of the EMF induced, that we can find it out. Let us see. Let us see, that is the E from 0 to 0 to 2. That is t equal to 0 to 2. What is the EMF induced? EMF induced is del B. Sorry, not del B. It is del phi by del t. So del phi you have already calculated. Del phi divided by del t. Del phi is simply the pi r square. Because 1 Tesla into pi r square, 1 Tesla into pi r square, Tesla should not be here. Tesla should not be here. Then pi r square in meter square, Tesla into meter square gives you the unit Weber. Okay, so pi r square Weber divided by 2. Now we can obviously put the value of the r. What is the value of the r? Let us see. It is given there. It is 12 centimeter. So you can put it here. If you wish, you can put the value is pi 0.12 meter. 12 centimeter equal to divided by 2. Here it is in second. Here it is in second. So Weber per second. So that is in volt. Okay, I hope you understood. Next we are going for t equal to 2 second, that is from t equal to 2 second to 4 second. The value of the b will not change. So let us write it down. From t equal to 2 second, from t equal to 2 second to t equal to 4 second. If I say the value of the magnetic field, it will remain 1 Tesla. At t equal to 2 second, it will remains 1 Tesla. And it is not changing up to the 4 seconds. So there is no change in magnetic field. Since there is no change in magnetic field, so there will be no change in the magnetic flux, because magnetic flux is del B multiplied by A. So that is also 0. Since del phi is 0 but del t is not equal to 0, that is 4 second minus 2 second. Del t is 2 second here. So E is equal to minus of del phi del t, or simply if I take the magnitude, there is no necessity of writing this negative sign here. So simply del phi by del t, okay, it will become 0 divided by 2. That means your 0 volt. No EMF is induced here. Now if I say from t equal to 4 second to t equal to 6 second, what happened? T equal to 4 second to t equal to 6 second. Let us check the graph again. T equal to 4 second to t equal to 6 second. The value of the magnetic field reduces from 1 to 0. So the value of the magnetic field is 1 Tesla when t equal to 4 second, and it is constantly drops at a constant rate and becomes 0 when t equal to 6 second. So if I check what is the value of the del B here, the value of the del B is from 0 Tesla to 1 Tesla. So this will become minus 1 Tesla. Okay. Now del T, what is the del T? What is the time interval? That is the 6 second minus of 4 second, that is equal to 2 second. Okay. So if you check it out, what is the value of the del phi here? Then del phi equal to del B multiplied by A. Del B is minus of 1 Tesla. Capital A is pi r square. Okay. So from here E is equal to del phi del T. Then it is E equal to minus del phi del T. If you put a negative sign here, then this will become simply pi r square. Pi r square divided by del T is 2, and this is in volt. So if I use the sign here, that is from 0 to 2 second. If I use the negative sign here, it is become minus. Okay, same value, but it is become minus. Okay. Now if I try to find it at what is the current, then obviously I have to divide these EMF values by the resistance 8.5. By the resistance 8.5 ohm, I have to divide it. Calculate the current induced in the loop. Then let us make a chart, that is time interval 0 to 2 second. Del T, time interval 0 to 2 second. What is the value of the EMF? EMF is, in the first case, it is pi r square divided by 2 volt. Clear? And what is the current here? Current is again divided, that is the pi r square divided by the resistance, that is a 2 multiplied by 0.85. In the time interval from 2 to 4 second, the EMF is 0, the current is also 0. Okay. In the time interval from 4 to 6 second, EMF is plus pi r square by 2, pi r square divided by 2 volt, and the current is pi r square divided by 2 multiplied by 0.85. I am just leaving this calculation new. You put the value of the R is 0.12 and just calculate this. Now if anyone want to plot this, that is the current with time. This is the time and this is the induced current. Okay, along the y-axis, this is the time. Current obviously in ampere, and the time obviously in second. Now this value, if I consider this is as I0, whatever the value you will calculate out, that is the pi r square divided by 2 into 0.85. The value of r is 0.12 whole square. Then from 0 to 2 second, this is the 0 second. From 0 to 2 second, this is the 2 second. From 2 second to 4 second. From 4 second to 6 second. So in the first 2 second, it becomes negative, and it is this. That is minus of I0. After that, From 2 to 4 second it becomes 0, that is it lies here. Okay, after 4 to 6 second, that is interval 4 to 6 second, it becomes again plus I0. That means let us consider here because constant and plus I0. So as long as the value of the magnetic field is changes periodically from 0 to 1 and again 1 to 0, the current is also changes from minus I0. I am also drawing here minus I0 to 0, then 0 to plus I0. Okay, let me draw it clearly. This is the plotting, that is the time, and it is the current. Current is at first from 0 to 2, it is negative to minus I0. Clear? Then from 2 to 4, it is 0. Then from 4 to 6, it is plus I0. Okay? So this is it. Thank you all.